right, so where we left off last time is in section 5.3. We were talking about special types of factoring. So we factored differences of squares. We looked at something called a trinomial square, and I told you if you want to factor that by the shortcut or not, really doesn't matter to me. And then we have one more bit of that section to do. So before we get into the new bit, I'm just going to give you two really quick warm-up problems just from where we've already been in this section. So here's the first one. Have fun, enjoy yourself with them. So the first one is going to be 64x squared minus, let's go something like 49. And then the other one, let's go 9x squared plus 30x plus 25. The first problem, difference of squares. I've given you no tricks or gimmicks, no common factors. These are both very straightforward problems, hopefully. So with the difference of squares, we're just unfoiling it. And so help me out. If my firsts multiply to give me 64x squared, with this being a difference of squares, what am I going to put in each parenthesis here? 8x. With my last being 49, what is going to be the last term for each parenthesis? 7 and 7. And then the trick to the difference of squares is making sure you put a plus in one, minus in the other. It doesn't matter which way, you put the minus and the plus, but the signs have to be different because when we refoil this, remember my outers and my inners cancel. They're no longer there. So that's how we end up with this. Any final thoughts or questions on difference of squares before we move on? This, now again, it's a trinomial. You can use the regular technique for a trinomial. If you want to use the grouping method that we talked about last time, great, it will always work for you. So if you decided to approach this by multiplying the 9 times the 25 and getting 225 and then messing around with your calculator till you found the two factors that added up to 30, beautiful, that's awesome. And if you know some other technique to factor in, great. But I did tell you that this may be what's called a trinomial square. The clue that it might be is that I've got a perfect square first term, a perfect square last term. And so let's see if it is. So the way I told you that we identify if it's a perfect square trinomial is we say, okay, 9 is 3 times 3. 25 is 5 times 5. We take one of the 3's times one of the 5's. That gives me 15. And from there, how do I identify if that's a trinomial square or not? What is the key bit? If this is half the middle. So is this half the middle term? Yes, so it does follow that pattern. So if you choose to remember this, it's a little quicker, okay, but it is one extra thing to remember. So there's a trade-off there. So if you do follow the pattern, then I'm just going to skip right to here. So that means I've got a trinomial square. So my first factor this time, since I have 9x squared, my first factor is going to be 3x of 3x. My last term, since this is a 25, is going to be 5 times 5. And since they have to add up to a plus 30, I'm going to put a plus between them. The key with the trinomial square is you get the exact same factor times itself. That's why it's called a trinomial square. Notice we do not rewrite this as 8x plus 7 squared or 8x minus 7 squared. These are different factors. You can't do anything else with it. Okay. Trinomial square, just a quick refresher. That's what we did last time. So I'm going to move on. If anybody's got anything they want to talk about, wave your hand. Say hello. Sounds good. So where we're going to end this section, and this is the last bit of factoring for us in this unit, these three sections. The last thing we're going to talk about is what's called a sum or a difference of cubes. Okay, so not squares this time, cubes. Now I'm going to define a couple terms there just in case you don't know what they are. Now we've mentioned previously, we mentioned last class when we first started talking about difference of squares, the word difference means to subtract. Okay, that's how you identify that, so still means that. The word sum, in case you're not familiar with the word sum, what does the word sum mean to do? Okay, it's add, okay, it's addition. And then a square is the same number times itself 2 times, so called because it's the size of a square if you're calculating the area. For much of mathematical history, before we enjoyed the cool notation that we have, the people did math by drawing pictures. And so the way you would notate that you were multiplying the same number times itself is you draw a square. Okay, so fun trivia. You can share that with friends at parties. A cube means I'm multiplying the same number times itself 3 times now. Okay, 1, 2, 3. Okay, so a cube is the same number times itself 3 times. In case you're not familiar with that term. Now, since we're probably less familiar with perfect cubes as we are with squares, let me just real quick, this will help us. Here are some of the perfect cubes. Just going to start the list and your calculator can give you more. By the way, on your calculator, I know we haven't talked about square roots and cube roots. That's our very last unit of this class. But your calculator can help you determine if something's a perfect cube with a cube root button. And if you don't know how to use the cube root button on your calculator, just see me after class. It'll take us 2 or 3 seconds to identify and show you how to manipulate that. But the perfect cubes, 1 cubed, 1 times 1 times 1 would be 1. 2 cubed, 2 times 2 times 2 is 8. 3 cubed, 3 times 3 times 3 is 27. So these are numbers. These numbers here would be classified as perfect cubes. 4 cubed, 4 times 4 times 4 is 64. 5 cubed, 125. I'm getting bored now. 6 cubed, I don't ever remember what 6 cubed is for some reason. I don't. 216, there we go. And I'll go one more just since I have the room for it. 7 cubed, 7 times 7 times 7, I think is 343, but I'm sure somebody will check me because who knows what's going on in my brain this morning. And they keep going, 8 cubed, 9 cubed, 10 cubed. Most of the numbers you'll encounter in this class are going to be fairly reasonable and manageable. But like I said, if you wonder if a number you're given on My Math Lab is a perfect cube, put it into your calculator, hit the cube root button, and if it comes out without a decimal, it is. Okay, and again, if you don't know how to use the cube root button, let me know. That's a quick fix right there. So all that to say, now, here we are, finally in our example, we're going to factor this, x cubed plus 27. I want to reiterate, just to make sure that I'm clear on myself. Last class, when we talked about differences of squares, you can only factor that when it's a difference, okay, a minus sign. If it's a plus, you cannot. But for cubes, we have more flexibility. Okay, we can do it whether it is a sum or a difference. So I'm starting out with a sum just to show you. Now, if you were to read through our book has a couple formulas for you. I try to limit formulas. I'm going to show you the pattern here. And this pattern works whether it's a sum or a difference. And once you've done it a couple times, hopefully it starts to stick in your brain. So when I factor a sum or a difference of cubes, there's always going to be 2 factors. Okay, so I'm going to have 2 sets of parentheses here. The first factor is always going to have 2 terms. And the second factor is always going to have 3 terms. Now, our first factor, the first 2 terms, this one I think is kind of straightforward to get to, hopefully. All you do for these two terms is you ask yourself, what's the cube root of each term? Or another way to ask that is what times itself 3 times gives you each term? So let's answer that question. What times itself 3 times, gives me x cubed? X times x times x, right? So I'm going to put an x right here. X times x times x. So what I'm doing for each of these two terms is I'm doing the cube root of the originals. And then this is a positive 27. The sign matters. Okay, so if you're in your calculator, you wouldn't put in a positive, but when this is a negative, we'll put in a negative in our calculator for the cube root. But what times itself 3 times gives us a positive 27? 3 times 3 times 3. It's on the list right over there. Okay, so this is going to be a plus 3. There's my first factor, my first pair of terms. Questions, comments, concerns so far? Now, the second one takes a little bit more effort, but what we're doing here is somebody at some point in mathematical history, they bumped into the fact by just multiplying things together, like we did with the difference of squares. Remember the first thing we did in section 5.3 is we multiplied x plus 9 times x minus 9, and we said, oh, cool, the outers and the inners cancel. Well, somebody did that with something like this and figured out the structure. So here we go. I'm going to start with the first term. Now, my firsts, this is going to be my first. I'm going to put a little f right up here for firsts. What here times x is going to give me x cubed? Perfect, x squared. Another way to think about this, if you don't like thinking about it like that, you can say x cubed divided by the x I've already put there. X cubed divided by x leaves me x squared for here. Those are my firsts. Okay? When I multiply these two things together, I get my firsts right here. I'm going to skip the middle. We're going to go to the lasts, my L. Same question. What am I going to put as my lasts here? That times this gives me 27. And again, another way to think about that, since we are factoring is unmultiplying something, 27 divided by 3 is what? 9. Now here's the middle. I think all of that is fairly straightforward. Okay? I know it's new and different and you got to get used to it, but I think it's fairly straightforward. Now what do we do? What's the middle? Because I need a middle term that if you did go ahead and multiply everything back together, you need a middle term that makes all the middle junk cancel out. So you just have the first and the lasts. And here's how you always find that. It's always going to be this. Take each of these terms, multiply them together. I should have structured this differently, so I'm just going to draw an arrow. I'm going to multiply the x times 3. What's x times 3? 3x. Now change the sign. Since this is positive 3x, what's the opposite of this? Negative 3x. There we go. I changed the sign. Yeah. If there's a different way that you see the structure, that is beautiful. I'm sure there's a dozen other ways. This is just the way my brain remembers it. So as we're going through, if you're like, hey, I see it this way, okay, no problem at all. Last thing I just want to note is I've just changed the sign here. So instead of positive, it becomes negative. And if you want to verify for yourself as homework, if you don't believe me today, why would you, then go ahead and multiply these two things together and see that because this is a minus 3x, that makes all the middle junk cancel out. That's always the structure. And I know that's kind of goofy and complicated, and you were hoping for something less stressful first thing on a Thursday with the weekend coming up. But we're going to do a few of these, and hopefully it gets a little easier to do. So here's your next one. It's going to be the same thing. It's going to be a sum of cubes, just different numbers for you to go ahead and run through this. So I would like you to do, please, a cubed plus 125. Okay, I'm gonna have two factors. The first one's gonna have two terms, the second one's gonna have three terms. So the first two terms are the cube roots. So if this is a cubed, what am I gonna write right here? This is a positive 125. What am I gonna write right here? 5 times 5 times 5 gives me 125. A times A times A gives me A cubed. Anybody got a concern so far? Please let me know. If something's not clear, if I'm not doing a good job, I need to know that. Okay, then my first here, what am I going to put as my first right here? Okay, A squared times A is A cubed. Or again, another way to think about that is my first here, A cubed, divided by my first here, A, leaves A squared for my firsts. I'm going to skip the middle again. I'm going to go to my last. What am I going to put here for my last? Again, 25 times 5 is 125. Or again, my last here divided by my last here, 125 divided by 5 needs to be 25. Use your calculator. Then the middle part of this. Here's how we get the middle. We do this. What's A times 5? 5A. And what do I get when I change the sign of that? Negative 5A. Put a negative 5A right there. Change the sign. Here's another one. Try this. I'm just going to change the sign. So if that befuddles you, that's okay. We're learning. We'll do another one with a minus sign in it, but give this a try. Let's see what happens when we have y cubed minus 64. Y cubed minus 64. What's going to be the first term right here? Okay, y times y times y is y cubed. Great. What's my second term? This might be where you made a mistake. Remember, it's okay. We're learning. What am I going to put right here? What's the cube root of negative 64? Negative 4. In case you didn't see that, cube roots function differently than square roots. Negative 4 times another negative 4 times another negative 4. When I multiply these first two together, a negative times a negative gives me positive 16. And then a positive times a negative gives me negative 64. So this time when I take the cube root, the sign matters. Okay, so this is going to be a negative 4 right here. Okay, so if you didn't get this first time, I'm going to give you another difference in a moment. You'll get to redeem yourself. All right, so what's going to be the first term on this one? Okay, y squared times y is y cubed. What's going to be the last term over here? Be careful with the sign. It's not going to be a negative 16, because if I put a negative 16 here, what's a negative times a negative going to give me? Positive 64. So this is going to be, let me do a better job erasing. There we go. This is going to be a positive 16, because a positive times a negative gives me a negative 64 right there. And then last but not least, when I multiply my two terms together, what's y times negative 4? What does that give me? Negative 4y. And when I change the sign on that negative 4y, it becomes positive 4. We followed the same pattern with a different sign. Okay, so if that goofed you up, remember that's okay. We're still learning. Here's your next problem that I'd like you to do. Smear this one right in. There we go. Let's try this. 8x cubed minus, I'm picking a number on my perfect cubes just to use a different number, 343. So the only different thing here, and it's really the last different thing, is I've got a number in front of the first term, but it functions the exact same way. So for my 8x cubed, what times itself 3 times is going to give me 8x cubed? 2 times 2 times 2 is 8. X times x times x is x cubed. I've got a negative, again, a minus sign, a negative 343. What times itself 3 times is going to give you negative 343? Negative 7, lovely work. And now we ask ourselves the same question that we have been. What am I going to put here for the firsts? Well, 8 divided by 2 is 4. X cubed divided by x is x squared. So I have a 4x squared right there. I'm going to go to the lasts. And so a negative 343 divided by a negative 7 is a positive 49. And then my middle term, I get by multiplying these two terms together. So 2x times negative 7 is negative 14x. And then I change the sign to a positive 14x. And there we go. There's my factoring of my difference of cubes. I've got 3 more problems for us, and we're done with this section. So if you've got a question, nail it down now. Let me know. I'm happy to help address anything that needs to be cleared up. Here's another one similar to that. Let's say that we have 64y cubed, and then we're going to go plus, and let's do 125 just for kicks. Once again, 2 factors. What's my first term of this one right here? Okay, 4 times 4 times 4 will give me 64. So 4 and y times y times y gives me y cubed. If you're not seeing where these numbers come from, please let me know so that I can write down more things and make it a little clearer. What number is going to go here? Okay, I've got a plus right here this time. I changed the sign on you, so hopefully you were awake. Plus 5. 5 times 5 times 5 is 125. That's the first one. That's the most important one. That tells us all the information we need for the second factor. And I've got 3 terms over here. So here we go. 64 divided by 4 leaves 16. Y cubed divided by y is y squared. So firsts. And then my lasts, 125 divided by 5 is 25. Lasts. And then the middle term over here, I multiply these 2 things together. 4y times 5 is 20y. Then I change the sign to a negative 20y. Second to last problem. 27x cubed plus y cubed. Okay, my purpose in giving this problem is this time the numbers on the left side, there's just a y cubed on the right. I just didn't want you to be intimidated by that. So again, if there's a question about what's going on. So again, what do I multiply 3 times to get this? And that's going to be 3x. 3 times 3 times 3 is 27. X times x times x is x cubed. And then over here, it's just going to be plus y. Y times y times y is y cubed. So we're dealing with these cube roots. So then 27 divided by 3 is 9. X cubed divided by x is x squared. So 9x squared. Firsts times firsts should give me firsts. Then y cubed divided by y is y squared. Y squared times y is y cubed. My lasts. Then I need that middle term that if I did take all the time to multiply everything together, makes all the middle stuff cancel out. 3x times y is 3xy. Change the sign, minus 3xy. All right, last problem, unless you have something you need to talk about. And so this is 3x cubed minus 192. So my purpose with this last problem is just like my purpose with the last problems for each section. At initial thought, this does not look like a difference of cubes, doesn't look like a difference of squares. So I'm tempted to want to give up. But before I do that, what is the first thing that we have often looked for before we've applied any of our factoring techniques? A common factor. Okay, so what you should do, grab your calculator if you need to, factor out the common factor here, and then factor what results. So the only number here in front of the x cubed is a 3. So I gave you the hint about the common factor. So it must be a 3. So when I factor out a 3 out of 3x cubed, hopefully you've got x cubed left minus, and your calculator will tell you when you take 192 divided by 3, I believe that is 64. It's a number we've already seen. And again, keeping the numbers reasonable, you're going to see a bunch of numbers repeated. So once you're used to seeing them, remember, this 3 is part of the final answer. Don't leave it off. Okay, it needs to be there at the end. And then here are my 2 factors. Same thing we've done 8 or 9 times already. What's the cube root of x cubed? X. What's the cube root of negative 64? Negative 4. In fact, I think we already did this problem. The only difference was the 3. My firsts, x cubed divided by x leaves me x squared. My lasts, a negative 64 divided by negative 4 is positive 16. And then when I multiply these 2 things together, I get negative 4x. I change the sign to plus 4x. And there's my factored expression. And that's done. That is sum and difference of cubes. I've got really nothing else to say about that. Yes?
How do you get a point order?
Cube root of each term. Okay, cube root means what times itself 3 times, gives you that term. So for x cubed, what 3 times? Well, x cubed is x times x times x. Okay, so I put an x there. That's called the cube root. And then for negative 64, that's negative 4 times negative 4 times negative 4. When you multiply those 3 things together, that gives you negative 64. So negative 4 is called the cube root. So you take the cube root of each term. Better? Excellent. Great question. Anything else?